problem statement is given here, and the data are given in a concise form. True length is equal to 50 millimeters. Point C is 10 mm in front of vertical plane and 15 mm above horizontal plane. An angle of inclination of the line with VP denoted by the symbol phi is equal to 30 degrees. The apparent angle of inclination of the front view is equal to 45 degrees. To draw the projections of the line CD, draw the XY line and then make use of the data that corresponds to the position of point C. So this is 15 mm above HP, therefore above XY line mark a point C dash at a distance 15 millimeters, and we can draw the top view of point C which comes below XY line and directly below C dash. Therefore draw a perpendicular from C dash and mark a point C at a distance of 10 mm below XY line. It is given the line is inclined at an angle 30 degrees to the vertical plane. The angle inclined to the vertical plane is visible in the top view when the line is parallel to the horizontal plane. Now we assume the line is parallel to horizontal plane and draw the top view. Therefore, we can draw a 30-degree line. Since the line is assumed parallel to the horizontal plane, we can see the true length in the top view. And true length is given as 50. Therefore, C as center, mark point D2 such that the distance C D2 is equal to 50. C D2 is the top view drawn assuming the line is parallel to HP. Originally the line is inclined to HP, but we don't know the angle. Of course, we need to calculate or find what is that angle of inclination with the horizontal plane. Therefore, here we use the symbol D2 and not D. The actual position of point D in top view is different from this one. But we know definitely point D in the top view will lie on a horizontal line through D2, and that line is locus of D. Draw the front view corresponding to the top view of C D2. Just to draw a projector from D2 and draw a horizontal from C dash, and it meets that horizontal line at D2 dash. So C dash D2 dash is the front view corresponding to the top view C D2. Remember, we assumed the line is parallel to HP while drawing this top view, and hence in the front view C dash D2 dash are at the equal height above XY line. We know the actual front view C dash D dash is equal in length of C dash D2 dash. So the original front view C dash D2 dash length is equal to C dash D2 dash. So now we know the length of the front view. What about the orientation of the actual front view? It is given the front view is inclined at 45 degrees to the XY line. That is, the apparent angle of inclination alpha is 45 degrees. Therefore, through C dash, draw a 45-degree line. On this 45-degree line, with C dash D2 dash as radius and C dash as center, draw an arc and obtain point D dash. So C dash D dash is the required front view. Now we need to draw the top view CD in order to complete the projections. And before that, through d dash we can draw a horizontal, and that gives the locus of d1 dash. That means d1 dash will lie on this one. So what is this d1 dash? C dash d1 dash represents the true length of the line in the front view, meaning C dash d1 dash is the front view, assuming the line is parallel to VP and inclined to the horizontal plane. So what is the angle of inclination of the line with the horizontal plane? We don't know. Of course, we need to calculate. In order to find that angle theta, we need to find the position of d1 dash. So C dash d1 dash is equal to true length, which is 50 millimeters. So take 50 millimeters in your compass, fix C dash as center, mark the point d1 dash, and join C dash d1 dash. And this length is equal to 50. And top view CD equal to CD1. So C is here. Where is D1? If you are able to find D1, then we can complete our projection by drawing CD. Also, we know the top view of the point D will lie directly below D dash. Therefore, we can draw a perpendicular from D dash. So that perpendicular intersects the locus of D over here. As a cross check, what can we do is find the CD1. So to find the position of D1, draw a perpendicular from D1 dash, and it intersects the horizontal through C at D1. Remember, C dash D1 dash is a front view, assuming the line is parallel to VP. Since the line is parallel to VP, its corresponding top view, C D1, and in C D1, point C and D are at equal distance from XY because the line is parallel to VP. Now make use of this concept CD equal to CD1, fix C as center and take CD1 as radius, draw an arc. Definitely it will pass through this point, and it is the position of point D in top view, join CD. So this completes the projection of the straight line corresponding to the position given. But we need to find what is the angle made by the line with the HP, that is theta. So where is theta? This angle is theta. That is the true angle of inclination. On measurement, it gives 38 degrees. Also, alpha, it is given directly 45. Phi is given as 30. And what is the apparent angle of inclination of the top view? Beta is equal to 40 on measurement you will get. Thank you.